Well, the next thing we are going to discuss is diagonal relationship. There is a diagonal relationship between beryllium of group 2A and aluminium of group 3. Beryllium and aluminium, they resemble each other in some of their properties, and this resemblance is described as diagonal relationship. This diagonal relationship, the reason for this relationship is similar polarizing powers of Be2 plus and Al3 plus cations. These two cations have similar polarizing power, and this is responsible for some similarities between the compounds of beryllium and aluminium. I'll give few examples to emphasize on this. Number one, their oxides are amphoteric. That means both beryllium oxide and aluminium oxide both are amphoteric. BeO and Al2O3 are amphoteric. This is first point of similarity. The next is regarding this. Their carbides are methanites. That means if you hydrolyze carbides of beryllium and carbide of aluminium, both give methane on hydrolysis. Look at this reaction. Be2C plus water, that gives rise to BeOH twice plus CH4. Let's make it 2, then this will become 4. So beryllium carbide on hydrolysis gives methane. Similarly, aluminium carbide Al4C3 reacts with water, undergoes hydrolysis, it produces aluminium hydroxide and methane gas. That makes it 12H2O. So you can see their carbides resemble in this manner, that they both give methane on hydrolysis. Number 3 is regarding hydroxides. Their hydroxides are soluble in excess of alkali. Their hydroxides are soluble in excess of alkali, like beryllium hydroxide. If you put it in alkali, it will dissolve as berylate. Similarly, aluminium hydroxide will dissolve in alkali to give aluminate. That will give you aluminate. AlOH taken 4 times minus. This is a similarity you can see. Apart from this, there is one more point of similarity in their chlorides. Both form polymeric chlorides with bridging chlorine atoms. You have already seen the structure of beryllium chloride and aluminium chloride. Just for the sake of revision, I'll put it once again. There's another point of similarity I'm going to discuss now. Another point of similarity is in their chlorides. Their chlorides contain bridging chlorine atoms. In their structures, they contain bridging chlorine atoms. Look at the structure once again. This is the structure of AlCl3. You can see it exists as a dimer. These are two molecules of AlCl3 which join in this manner and form a dimer. So these two chlorines are bridging chlorines. These are terminal chlorines. It has got 4 terminal chlorines and 2 bridging chlorines. You can visualize this structure something like this. Both aluminium and 4 terminal chlorines are lying in the same plane, and the bridging chlorines are present one above and one below the plane. Now look at the structure of beryllium chloride. This is one molecule of beryllium chloride. This is another molecule. Again you have another molecule. This is how they are linked up, and it continues. So it forms a polymeric structure. So what is the similarity in these two structures is presence of bridging chlorine atoms. You have in both the cases you have bridging chlorine atoms. So this is regarding diagonal relationship between beryllium and aluminium. I told you, once again I want to tell you, the reason for the diagonal relationship is because of similar polarizing power of Be2+ and Al3+.